Right now, sitting on a laboratory table somewhere in Europe, there is a blueprint to build a literal wormhole for exactly 48,000 euros.
Which is just wild to even say out loud.
It really is. I mean, it's not a metaphor, not some science fiction thought experiment. We were talking about a macroscopic physical tunnel through the fabric of space-time.
Yeah, and the engine that drives it relies on standard radio frequencies and a very specific type of bismuth crystal.
Right. And you know, the wildest part of all of this, an artificial intelligence researcher just proved that the exact same tensor calculus required to fold physical space works right now, today, inside large language models.
It's basically a profound collision of two disciplines that, normally don't even speak the same mathematical language.
Right.
You have theoretical astrophysics intersecting directly with neural network topology.
It's crazy. So welcome to the deep dive. Our mission today is to unpack a massive stack of highly technical source material with you.
And it's a dense stack, let me tell you.
Oh, absolutely. So if you are joining us, we are tearing into the independent research of Rodolfo Rossetti, specifically his framework on Torsiodynamics.
Right.
Alongside that, we're analyzing an empirical validation paper by Elijah A. Brown. He's the AI researcher who took Rossetti's physics and injected them straight into a GPU.
To really understand what we're dealing with here, we have to, establish the sheer gravity of these sources. Rossetti's papers are not just speculative musings.
No, not at all.
They're grounded in rigorous Einstein-Cartan-Maxwell tensor calculus. I mean, they detail exact requirements for exact scale supercomputers. They lay out a phase 1 business plan down to the single euro.
It's hyper-specific.
Exactly. The math is dense, the engineering specs are incredibly detailed, and the implications, well, they challenge everything we thought we knew about the boundaries of physics and data.
Yeah, so I want to start with the physics, actually, because for decades, the rule book has been pretty inflexible.
Very inflexible.
Like, if you take a high school physics class, or even an undergrad course, the professor stands at the chalkboard and tells you that traversable wormholes are impossible unless you have something called exotic matter.
Right, which is this highly theoretical stuff with negative energy that probably doesn't even exist in our universe.
Exactly. But Rossetti claims to have solved this entirely without exotic matter. And the reason is because he isn't playing by the standard rules of general relativity, is he?
No, he's operating in a fundamentally different mathematical framework. Standard general relativity, the model Einstein, published in 1915, the one we've all been taught, it relies on a Riemannian background.
Okay, a Riemannian background. Break that down for us.
So in differential geometry, a Riemannian manifold only accounts for the curvature of spacetime. It just deals with how mass bends the fabric.
So I want to avoid the usual bowling ball on a trampoline analogy because, I don't know, it feels a bit tired.
Fair enough.
Let's think about it like a tightly stretched sheet of Kevlar, right? If you drop a massive lead weight onto that Kevlar, it pulls the fabric down into a deep funnel. That's curvature.
That works well as a visual, yeah.
That's gravity under standard relativity.
Right. And under standard general relativity, the rules governing that Kevlar sheet dictate something called the null energy condition.
The null energy condition.
Yeah, it's a mathematical way of stating that gravity, produced by any normal mass or energy, is always an attractive force. It always pulls. It never, ever pushes.
So if you try to punch a hole through the bottom of that Kevlar funnel and connect it to another sheet-like, creating a wormhole throat, the gravity of the surrounding mass is just going to violently crush that tunnel close.
Exactly. You would snap shut instantaneously. It wants to pull everything inward.
So how do you stop that?
Well, to keep a theoretical wormhole throat from collapsing under standard relativity, you would need a localized force that pushes outward with immense power. You need repulsive gravity.
And because normal matter only pulls, physicists had to invent exotic matter.
Right. Fluids with negative energy or negative mass, just to balance the equations and, artificially hold the throat open on paper.
But nobody has a jar of negative energy sitting on a shelf. So wormholes remained mathematically interesting, but physically impossible.
Until Rossetti.
Enter Rossetti and his use of Einstein-Cartan-Maxwell theory. What does the Cartan and Maxwell bring to the table that changes this rigid rulebook?
So what Einstein-Cartan theory does is introduce a completely new dynamic variable to the geometry of the universe. It doesn't just look at how the Kevlar sheet bends. It introduces geometric torsion.
Torsion. So instead of just dropping a lead weight to stretch the Kevlar, torsion is like grabbing the center of the fabric and violently twisting it into a tight, spiraling knot.
Yes, exactly. You're introducing a rotational shear to the space itself. The physical twist of the manifold is the critical mechanism here.
Okay.
And Rossetti's papers leverage a very specific mechanism called non-minimal electromagnetic coupling.
Okay, that is a lot of syllables. I read that section of the source material 3 times, and I still felt like I was drowning in equations. What does non-minimal electromagnetic coupling actually mean for the physical space?
Let's break down the mechanism. In standard models, electromagnetic energy, like a radio wave or a beam of light, travels through space, and its mass energy equivalent causes a tiny, almost imperceptible amount of curvature.
Barely enough to measure.
Right. But in Rossetti's Einstein-Cartan-Maxwell mathematical framework, the electromagnetic energy is directly converted into geometric torsion.
Wait, so the radio wave physically grabs the fabric of space and twists it?
Exactly. The electromagnetic field directly couples to the torsional field. You're taking raw electromagnetic power and using it as a geometric engine to wrench the manifold.
That's wild.
And this is where the physics fundamentally shift. The math in Rossetti's paper shows that the quadratic torsion terms in the equations generate an effective positive pressure.
Wait. The physical act of twisting the space generates an outward pushing pressure.
Yes. It creates a tremendous repulsive force. This torsional pressure fundamentally transmutes the null energy condition.
So you don't need exotic matter.
You don't need to scour the universe for imaginary exotic fluids at all.
Yeah.
You just need to twist the fabric of space-time hard enough with electromagnetism, and that generated pressure naturally pushes outward.
Effectively creating repulsive gravity to hold the wormhole throat open.
Precisely.
I have a massive problem with this, though.
Okay, what is it?
Well, if twisting space-time is the secret to unlocking repulsive gravity and building wormholes, why didn't Einstein or Stephen Hawking or any of the brilliant minds of the 20th century just do that?
That's a very fair question.
Like, why is this independent researcher in the 2020s the first one bringing this to the table as a viable macroscopic engineering project?
The historical context here is vital, honestly. Élie Cartan, who was a brilliant French mathematician, actually introduced the concept of torsion to Albert Einstein back in 1922.
Wait, really? In 1922?
Oh, yeah, they corresponded extensively about it. It was incorporated into the Einstein-Cartan theory, so it isn't a new concept.
Then why was it abandoned?
Well, it wasn't exactly abandoned. It was relegated to the microscopic realm. In standard astrophysical models, torsion usually only couples to quantum spin densities.
Meaning it only affects subatomic particles.
Exactly. It matters profoundly if you're looking at the spin of an electron or a quark inside an atom.
Right.
But at the macroscopic scale, the scale of stars, planets, human beings, the effects of geometric torsion were mathematically proven to be so infinitesimally small that they were completely washed out by the dominant force of standard curvature.
Okay,
Yeah.
so the physics community looked at torsion, said, well, this only matters for tiny particles, it doesn't affect big things, and essentially just zeroed it out of their macroscopic equations to make the math manageable.
Exactly. It was a perfectly reasonable assumption for a century of astrophysics.
Right.
Rossetti's actual breakthrough isn't discovering torsion. His breakthrough is figuring out the mechanism to scale it up.
Scaling it up.
Yes. He developed a framework using specific metamaterials and electromagnetic resonance to artificially amplify this tiny quantum twist into a massive macroscopic spacetime distortion.
We are definitely going to get into those specific materials shortly because the engineering specs are wild. But before we build it, we really need to understand the shape of what we are building.
Right, the topology.
Because if torsion is the key, what actual shape does this twisted space-time take? I'm assuming we aren't just tying space into a random knot.
No. Geometry dictates function here. The equations require a very specific topological shape. It's called a logarithmic spiral tubular wormhole.
A logarithmic spiral. Okay, if you're listening, picture the shell of a nautilus or the sweeping arms of a spiral galaxy, or even the bands of a hurricane, right?
Yes.
It's a spiral that gets progressively tighter as it moves inward.
That's a perfect visual. The mathematical foundation for this shape relies on what's called the Frenet-Serret invariance.
The Frenet-Serret invariance.
Anytime you define a curve in three-dimensional space, it possesses two fundamental defining properties at any given point along the curve. Its curvature, denoted by the Greek letter kappa.
Which is how severely the line bends away from being straight.
Right, and its geometric torsion, denoted by tau sub c.
Torsion is how severely the line twists out of a flat two-dimensional plane, like a corkscrew pulling upward.
Exactly. And in this logarithmic spiral, as you travel down the funnel toward the absolute narrowest point, what physicists call the throat of the wormhole.
Where the radius, The dollars approaches zero.
Right, as Triddle broke to zero, Rossetti mathematically proves what he calls the torsional shield theorem.
Yes. I spent a lot of time on the torsional shield theorem in the notes. It states that as the radius approaches zero, the effective potential diverges to positive infinity.
Yes.
Walk us through the physical reality of what diverging to positive infinity means for an object actually trying to pass through.
Functionally, it creates a wall of energy.
Oh.
As the spiral gets infinitely tight at the throat, the torsional pressure we discussed earlier spikes astronomically.
Wow.
It creates what the physicist Dr. Jacques Sarfati originally termed a white hole force shield.
A white hole force shield. I mean, it sounds completely like science fiction.
It does, but the sources show Rossetti mapped this out using some serious computational firepower.
Right, the numerical validation.
Yeah, he used an algorithm called DOP853. It's a high-precision integration tool designed to solve complex differential equations. And crucially, DOP853 conserves energy to a machine precision of the order of 10 to the negative 13th power.
Meaning the math isn't just a rough approximation, it is airtight down to 13 decimal places.
Exactly. The simulation accounts for almost every stray fraction of energy.
And the precision is what makes the resulting phase space diagrams so compelling, right?
Yes. When he ran the algorithm to map out the particle trajectories, meaning how an object would actually travel through this spiral, the phase space revealed a massive chronological asymmetry.
Yeah, I was staring at these phase space portraits. Let me see if I have the visual right for the audience. The graphs plot the energy and position of particles moving through the wormhole.
Great.
The inbound trajectories, like particles or ships or light trying to enter the wormhole from our side, are coded red. And these red lines swoop in, hit a literal vertical wall on the graph, and completely bounce off. They reflect backwards.
Exactly. The extreme torsional gradient, the violent tightening of that geometric twist, decelerates any inbound particle to a complete halt, and then violently reflects it back the way it came.
It is an impenetrable barrier.
It is.
But the outbound trajectory stuff coming from the other side of the wormhole into our space, which are coded green, they don't hit a wall.
No, they don't.
The graph shows them experiencing a gently sloping potential. They just slip right through the throat and exit into our space. It's literally a one-way street.
It acts exactly like a macroscopic diode for matter and energy. The asymmetry is extreme.
Okay, I have to push back here. If it's a one-way street, how is it a traversable wormhole?
What do you mean?
Well, if I try to fly a ship into it, I just bounce off the white hole force shield. What is the point of a door you can only walk out of?
I see. Well, you are looking at a single funnel. The Phase 3 engineering roadmap addresses this by utilizing a binary spiral architecture.
A binary spiral architecture?
Yes. You need two interconnected transmitters operating with inverse phase relationships. One acts as the entrance, dampening the local shield, while the other acts as the exit.
Oh, okay.
But more importantly, from a pure physics standpoint, this asymmetrical bouncing effect is exactly what makes the single throat stable in the first place.
How does bouncing inbound matter stabilize the throat?
Because it naturally prevents the throat from collapsing in on itself under the weight of external vacuum fluctuations.
Oh, I get it.
The geometry actively defends itself from inbound microscopic energy that would normally destabilize a general relativity wormhole. The torsional shield pushes out against the universe, trying to crush it.
That makes an unsettling amount of sense. The sheer hostility of the entrance is what keeps the tunnel from collapsing?
Exactly.
But speaking of collapsing tunnels, you cannot publish a massive treatise on time travel, wormholes, and space-time manipulation without directly confronting the ghost of Stephen Hawking.
You were referring to his chronology protection conjecture.
Absolutely. Hawking's chronology protection conjecture is essentially the bouncer at the door of theoretical physics. Hawking argued that the universe will physically, violently prevent time travel in traversable wormholes to protect the laws of cause and effect.
Yes.
So how does Rossetti's framework survive that?
Well, Hawking's argument was mathematically terrifying for wormhole theorists. He proposed that if you managed to create a traversable wormhole or a time machine, the quantum vacuum energy of empty space would begin to loop through it.
Imagine putting a microphone too close to a speaker. A tiny bit of background noise goes into the mic, comes out the speaker louder, goes back into the mic even louder, and within 3 seconds you have this ear-shattering, screeching feedback loop.
A perfect analogy. Hawking mathematically demonstrated that at the Cauchy horizon, the absolute boundary of the time machine, where the timeline loops back on itself, this quantum vacuum energy would diverge.
Diverge meaning?
It would rapidly amplify toward infinity. The energy density would become so massive that it would instantly destroy the wormhole in a catastrophic gravitational collapse.
So the universe's own background static amplifies until it blows up the tunnel.
Exactly.
And Hawking's math on this was considered bulletproof for 30 years. But Rossetti claims to have formally destroyed this conjecture at both the classical and semi-classical levels. How do you destroy Stephen Hawking's math?
You realize that Hawking's math was built on an incomplete foundation.
Incomplete how?
Hawking's calculations were bulletproof, yes, but only if you assume a rigid, torsionless Riemannian background. He relied entirely on standard general relativity. He completely missed the torsion.
Because he was ignoring the twist, just like everyone else.
Exactly. In an Einstein-Cartan framework, Rossetti outlines what he calls the torsional discharge limit.
The torsional discharge limit.
Right. Because Hawking didn't include geometric torsion, he failed to see that the twist of spacetime acts as a geometric capacitor.
Let's unpack that. How does the space twisting act like a capacitor storing energy?
The axial torsion of the spacetime twist introduces what particle physicists refer to as a topological mass gap. Mathematically, it's represented as delta E is proportional to eta times tau sub c.
Okay, I need that translated. What does a topological mass gap actually do in reality?
It acts as a natural geometric ultraviolet cutoff. In physics, an ultraviolet cutoff is a theoretical limit that prevents calculations from running away to infinity.
Ah, okay.
When Hawking calculated the vacuum energy, it went to infinity. But Rossetti shows that when you integrate the quantum vacuum modes in a space that is severely twisted, the result yields a strictly finite number.
The screeching microphone hits a volume limit.
Exactly. The energy cannot reach infinity because the geometric twist simply absorbs the stress.
It's like installing a lightning rod on the wormhole.
That's a great way to put it.
Right. Like, Hawking thought the infinite lightning of quantum vacuum energy would strike the tunnel and burn the entire structure down to the ground. But Rossetti is proving that the Einstein-Cartan math automatically installs a torsional lightning rod.
Yes.
It safely absorbs the infinite voltage, grounds it, and caps the energy.
And the math caps it specifically at the torsion value to the fourth power divided by 4. It is a strictly finite result. The geometry fundamentally absorbs the energy that would have caused a singularity. Hawking's screeching feedback loop is physically dampened by the twist of the space itself.
So the chronology protection conjecture is completely bypassed.
Correct.
Okay, this is the exact moment where the deep dive takes a hard left turn into reality, because up to this point, we have been living in the realm of chalkboards and supercomputers.
Theoretical physics, yeah.
Right. We defeated Hawking on paper, but Rossetti isn't just a theorist. He provided the actual physical engineering parameters to build this thing. He designed what he calls an RF engine.
This is where we transition from differential geometry to applied aerospace and electromagnetic engineering. Rossetti's sources outline the core of the machine. It is based around a parabolic radio frequency, or RF, transmitter.
If you're picturing it, think of a massive satellite dish or a radar installation, a parabolic curve designed to focus waves.
The shape is standard, yes, but the material science is where the breakthrough occurs. The transmitter surface must be coated with a highly specific metamaterial.
Bismuth-doped yttrium iron garnet.
Exactly. It is referred to in the literature as BiYiG.
BiYiG. Why this insanely specific crystal? Like, if we just need to pump radio waves, why not use highly conductive copper or gold or aluminum?
Because normal conductors simply cannot handle the physical mechanism required here. Bismuth is the critical element because its massive atomic nucleus provides extreme spin-orbit coupling.
We need to unpack spin-orbit coupling. What is actually happening inside the bismuth atom?
Imagine an electron orbiting the nucleus of an atom. The electron has its own intrinsic spin, like a top spinning on its axis. But it's also moving in a circular orbit around the nucleus.
Okay, I got the picture.
From the perspective of the moving electron, the stationary nucleus appears to be orbiting it, generating a magnetic field. Spin-orbit coupling is the interaction between the electron's own spin and the magnetic field generated by its orbit.
So the electron spin gets locked into a relationship with the magnetic field.
Because bismuth has such a massive, heavy nucleus, this coupling effect is incredibly strong. When you hit standard materials with massive megawatt-level radio frequency waves, the energy just agitates the atoms.
They heat up, and eventually the material melts or vaporizes.
Right. But BiYiG reacts differently. Because of that extreme spin-orbit coupling, it doesn't just turn the energy into waste heat. It acts as a geometric lens.
A geometric lens. It takes the incoming standard radio wave, and instead of just bouncing it, it physically polarizes the wave into that exact logarithmic spiral shape we discussed earlier.
Yes. It translates raw electromagnetic wave energy directly into a macroscopic spacetime twist without burning up. The technical description in the paper is that the BiYIG coating creates a macroscopic Fröhlich condensate, where the U1 gauge symmetry is spontaneously broken.
Okay, stop right there. Macroscopic Fröhlich condensate, where U1 gauge symmetry is spontaneously broken. If we don't explain that, we are going to lose everyone.
Understood.
Let's start with a Fröhlich condensate.
Herbert Fröhlich theorized that under certain conditions, biological systems or specific lattices could funnel vibrational energy into a single, highly ordered state.
Like what?
Imagine a stadium full of people all clapping at random times. It's just chaotic noise.
Huh.
A Fröhlich condensate is what happens when suddenly everyone in the stadium syncs up and claps at the exact same millisecond.
Oh, wow.
The energy is identical, but the order creates a massive unified wave.
So the BiYIG crystal takes chaotic, hot radio wave energy and forces all the atomic vibrations to sync up perfectly.
Yes, and when they sync up, they cause a spontaneous breaking of U1 gauge symmetry.
And U1 gauge symmetry breaking means what exactly?
In quantum field theory, U1 gauge symmetry is the mathematical rule that governs electromagnetism, how light and magnetic fields behave. Breaking a symmetry sounds destructive, but it actually means acquiring a physical structure.
Okay, give me an example.
Think of liquid water. In liquid water, molecules can move in any direction. It has high symmetry. But when it freezes into ice, that symmetry is broken. It chooses a specific crystalline structure.
Ah. So the BiYIG crystal forces the electromagnetic energy to freeze into a specific, rigid, torsional structure that can directly push against the fabric of gravity.
That is exactly what connects the electromagnetic power to the gravitational metric. And the numbers provided in Rossetti's sources for this operation are incredibly rigid. You cannot just turn on a radio and twist space.
Right, there are specific constraints.
The system must be pumped at the exact geometric resonance frequency of 45.01 megahertz.
45.01 megahertz. It has to be exactly that frequency.
It must, because at exactly 45.01 megahertz, the electromagnetic wavelength traveling through a vacuum is exactly 6.66 meters.
6.66 meters. A highly specific, slightly ominous number. Why 6.66 meters?
Because mathematically, it is perfection. Rossetti calculates that 6.66 meters perfectly matches the macroscopic throat diameter of the logarithmic wormhole predicted by the Einstein-Cartan equations.
He calls this phenomenon spacetime cavity resonance, right?
Yes, he does.
It's like blowing across the top of a glass bottle. If the air wavelengths doesn't match the cavity of the bottle, you just get a rush of wind. But if the wavelength matches perfectly, the bottle resonates and produces a loud, sustained note.
The electromagnetic wave fits the space-time hole perfectly, creating resonance. Furthermore, the electrical impedance matching of the RF system must hit exactly 482.45 ohms.
Impedance is electrical resistance, so the circuit has to have exactly 482.45 ohms of resistance. What happens if you are off by a few tenths of an ohm?
If the impedance doesn't match exactly, the power doesn't transfer into the vacuum. You get massive thermal reflection.
Meaning?
The megawatt energy bounces back into your transmitter and your laboratory violently explodes. But if you hit 482.45 ohms precisely, you achieve 100% power transfer into the space-time manifold.
Okay, let's talk about that power, because this is the biggest red flag I saw when reading the source documents. The paper cited a requirement of 500 megawatts of power.
Yes. 500 megawatts.
500 megawatts is not a tabletop experiment. That is half the output of a commercial nuclear power plant. How can Rossetti claim this is manageable if you need a nuclear reactor to turn it on?
This is a point of frequent misunderstanding that Rossetti addresses explicitly in the engineering breakdown.
Yeah.
You do not need 500 megawatts of continuous sustained power.
Okay.
He details a physical phenomenon called topological hysteresis.
Hysteresis. Usually we hear that term in magnetism, right?
Yes.
Like if you rub a piece of iron with a strong magnet, the iron stays magnetic even after you take the original magnet away. The system remembers its state, it holds the shape.
That is the principle. In this context, the 500 megawatt requirement is only the peak power required for ignition. You only need to hit the BiYIG crystal with 500 megawatts for about 222 microseconds.
222 microseconds. That is a fraction of a millisecond.
It equates to exactly 10,000 wave cycles of that 45.01 megahertz frequency. You can easily achieve a 222 microsecond burst of 500 megawatts using standard military-grade capacitor banks.
Oh, I
You
see.
charge up massive batteries slowly over hours and then dump all the energy in a fraction of a second. No nuclear reactor required.
Okay, so you dump the massive burst of energy, the space-time topology fractures, the resonant 6.66 meter throat opens. Then what? The capacitor bank is empty.
This is where topological hysteresis takes over. Once the geometric twist is established in the manifold, the wormhole begins acting as a torsional filter.
A torsional filter.
The extreme rotational shear starts passively absorbing ambient quantum vacuum fluctuations from the surrounding empty space.
So the wormhole starts feeding on the background static of the universe to hold itself open.
Yes, the geometry becomes self-sustaining. And because of that vacuum absorption, the active power requirement from the RF transmitter instantly plummets from 500 megawatts down to a continuous wave of just 3.5 megawatts.
3.5 megawatts is dramatically different. A local hospital backup generator system can output 3 megawatts. You could run the sustained wormhole off a heavy industrial power grid.
Exactly. Building a localized burst capacitor system and sustaining a 3.5 MW field is essentially phase 3 of Rossetti's roadmap. It is a massive industrial undertaking, but it is fundamentally achievable with currently existing human technology. We do not need to invent new physics to power it.
But right now, Rossetti isn't asking for the billions of dollars required to build phase 3. Which brings us to the most pragmatic and frankly surreal document in this stack Progetto Torsiodynamica, the business plan.
Yes, the phase 1 plan.
Rossetti is currently looking for seed funding for phase 1, and phase 1 literally fits on a laboratory table.
The document titled Business Plan Scientifico outlines phase 1 with meticulous forensic detail. It is designed as a low-power proof-of-principle experiment. He isn't trying to open a 6-meter tunnel. He is using a 50 to 100 watt output to create a microscopic metric distortion. And he has budgeted the entire hardware setup down to the single euro. The cost is exactly 48,000 euros.
48,000 euros. That is less than the price of a mid-size SUV. You are telling me someone can empirically prove the existence of space-time manipulation, upend general relativity, and win an inevitable Nobel Prize for the cost of a Honda Pilot.
It sounds absurd, but yes.
How is the setup so incredibly cheap?
By relying on extreme precision rather than extreme power, he is substituting megawatt brute force with highly sensitive optical and mechanical detectors.
Okay.
The phase 1 setup relies on a hybrid detector system designed to measure the absolute faintest ripple in local gravity.
I want to break these detectors down clearly. What is the primary detector sitting on this 48,000 euro table?
The primary instrument is a Sagnac interferometer.
Let's visualize a Sagnac interferometer. It uses lasers, correct?
Yes. A central laser beam is split by a mirror into 2 separate identical beams. These 2 beams are then routed along a circular track, usually a fiber optic coil or a ring of mirrors around the central target area.
And the target area is the BIYIG emitter.
Right. One laser beam travels clockwise around the ring, while the other travels counterclockwise.
So you have 2 light beams racing each other in opposite directions around a track.
Under normal circumstances, when the RF generator is turned off, the speed of light is constant. Both beams travel the exact same distance at the exact same speed, and they hit the finish line, the optical sensor, at the exact same microsecond.
Okay.
But if Rossetti is right, when you turn on that 45.01 megahertz radio pump, the BIYIG crystal will induce a localized spacetime twist. It will cause a phenomena called frame dragging.
Frame dragging, the space itself begins to spin like water circling a drain. Let me try an analogy here. Imagine you are at the airport, and you are running on one of those flat, moving walkways. If you run in the same direction the belt is moving, your speed relative to the terminal increases drastically. You are running, plus the belt is carrying you.
Yes.
But if you turn around and try to run against the movement of the belt, you slow to a crawl relative to the terminal. The moving walkway is fighting your momentum.
That is an excellent mechanical analogy for frame dragging. The BIYIG crystal turns the physical vacuum of space into a circular moving walkway.
So because the space itself is spinning, it physically slows down the laser beam that is traveling against the rotational shear, and it accelerates the laser beam traveling with the shear.
Exactly. And because light speed locally appears to shift relative to the laboratory frame, when the 2 beams hit the final sensor, they will no longer be perfectly synced. One will rise slightly behind the other.
Fascinating.
This microscopic delay creates a measurable phase shift, an interference pattern on the sensor. That pattern is definitive, irrefutable proof that the local metric of spacetime has been physically altered.
It is a binary, undeniably clear test. You turn the radio off, the lasers align. You turn the radio on, the lasers shift. You have twisted space.
Yes.
But experimental physics hates a single point of failure. He didn't stop with just the lasers. He built a secondary detector into the budget.
Always have a mechanical backup for an optical system. The secondary detector is a polarized torsion pendulum.
This sounds like a modified Cavendish balance. For the listeners, the Cavendish experiment was how physicists first measured the gravitational constant of the Earth hundreds of years ago. You hang weights on a string and watch how gravity pulls them.
It operates on the exact same principle, but modernized. Rossetti's setup suspends a microscopic ferromagnetic test mass from an incredibly thin quartz thread.
Okay.
This mass is placed millimeters away from the BiYIG emitter. Attached to the quartz thread is a tiny mirror. You shine a laser pointer at the mirror, and the reflection bounces onto a wall across the room.
The laser pointer amplifies the visual movement. If the thread twists even a fraction of a millimeter, the dot on the wall moves by several inches.
Precisely. When the RF transmitter is powered up, the portional gradient, the physical gravity well created by the twisting space, will induce an anomalous mechanical deflection.
The pendulum will literally swing toward the altered gravity.
The thread will twist, the mirror will turn, and the laser dot on the wall will move.
You measure the dot's movement, and you calculate the exact gravitational pull of the wormhole. It is a brilliant, elegant experiment. So if phase 1 proves it works for 48K, what comes next?
The roadmap is clearly defined. Phase 1 provides the empirical proof to secure major funding. Phase 2 requires an investment of 2.5 to 3 million euros.
Where does that money go? Are we building the giant satellite dishes yet?
No, Phase 2 is purely computational. The bulk of that budget is for renting massive amounts of time on an exascale supercomputer, specifically targeting a system like the Seneca facility in Italy.
Wait, why do you need a supercomputer if you already proved the physics work on a table?
Because you need to learn how to steer. Proving you can twist space is like proving you can build a sail. But you still need a map to cross the ocean. Phase 2 involves the 4D integration required to calculate exact point-to-point cryptographic transport coordinates.
Transport coordinates.
Yes. You need the supercomputer to simulate exactly how to modulate and tune that 45.01 megahertz pulse to ensure that when the 6-meter throat opens, it connects point A on Earth to a specific point B in orbit.
Or point B in another solar system.
Exactly. Rather than just opening randomly into the vacuum of space or the center of a star, you have to map the topology of the universe to navigate it.
That makes sense.
Only after the navigation is solved do you move to Phase 3, the multi-billion-dollar construction of the binary spiral architecture. 2 massive parabolic dishes opening a macroscopic, stable, bidirectional tunnel.
Now I have to step in here as the skeptic. Making claims of this magnitude overthrowing Stephen Hawking, redefining a century of general relativity, proposing a tabletop experiment that breaks the laws of physics as we know them, that invites some incredibly intense scrutiny from the academic community, and the sources we have include a pretty fiery peer review exchange.
Yes, the Northey rebuttal. When you attempt a paradigm shift, the establishment strikes back with rigorous mathematical force.
Yeah. Dr. Julian Northey, an independent peer reviewer, submitted highly technical objections to Rossetti's work.
He did.
I was reading through the Northey rebuttal, and to be honest, it looked like he was trying to tear the entire foundation down to the studs. He pointed to this specific piece of math, this term labeled G subs P.
Yes, the G sub Beck artifact.
And he basically accused Rossetti of having a metric inconsistency. He was saying the math was fundamentally broken. I actually had to pause there because if Northey is right about this metric inconsistency, the wormhole collapses on paper before anyone even buys a laser.
Northey attacked on 3 fronts. First, the metric inconsistency involving the GSP term, which is an off-diagonal element in the metric tensor that he claimed violated the boundary conditions.
Right.
Second, he questioned the dynamical stability of the wormhole under perturbation. And third, he challenged the gauge invariance of the electromagnetic coupling.
Let's focus on that first massive attack, the metric inconsistency. Because if the foundation is cracked, nothing else matters. How did Rossetti counterattack the GSP problem?
Rossetti's rebuttal is clinical and mathematically ruthless. He demonstrates step by step that the GSP term Northey pointed out is nothing more than a spurious coordinate artifact.
Okay, stop right there. A spurious coordinate artifact. I have to push back incredibly hard here.
I expected you might.
Erasing a problematic mathematical term by calling it an artifact and applying what Rossetti calls a radial diffeomorphism. That sounds incredibly convenient. It sounds like cooking the books to make the physics work.
It does sound like that to a layperson, yes.
How do we know Rossetti isn't just hiding a fatal throat-collapsing flaw behind a fancy mathematical trick?
I completely understand the skepticism, but you have to understand how differential geometry works. Coordinate artifacts are not cooking the books. They are a known, rigid feature of mapping curved spaces.
Okay.
The most famous example in all of astrophysics is the Schwarzschild radius of a black hole.
The event horizon.
Yes. When Carl Schwarzschild first solved Einstein's equations for a black hole in 1916, the math at the event horizon literally blew up to infinity.
It did?
Yes. For decades, the greatest physicists in the world thought that at the event horizon, space physically tore apart and time literally stopped because the mathematical terms went to infinity.
But time doesn't stop and space doesn't tear. If you fall through an event horizon, you don't even notice crossing the boundary.
Exactly. The physical space there is perfectly smooth. The coordinates blew up, not the reality. Let me give you a terrestrial analogy. Look at a standard Mercator projection map of the Earth, the flat map you see in every elementary school.
On that map, Greenland looks massive. It looks larger than the entire continent of Africa.
But in reality, Africa is roughly 14 times larger than Greenland.
Right. The massive size of Greenland on the map is a coordinate artifact caused by stretching a 3D globe onto a flat 2D rectangle.
Yes. The land itself didn't grow. The mathematical grid used to draw it was distorted at the poles. A diffeomorphism in differential geometry is essentially the mathematical process of translating that flat, distorted map back onto a 3D globe.
Ah, okay. So Rossetti proved that Northey was looking at a distorted Mercator map of the wormhole.
Precisely.
Northey saw this huge dollar term and thought it broke the universe, but Rossetti applied a globally regular radial diffeomorphism, specifically substituting Furley-Kloeber, and showed that on a mathematically accurate globe, the term completely vanishes.
Exactly. By applying that transformation, the problematic term is entirely absorbed, leaving behind the physically correct, stable 4D spacetime metric.
Wow.
The geometry is completely sound, regardless of the flawed grid Northey initially tried to draw over it.
Okay, I concede the coordinate artifact. That makes perfect sense. But what about Northey's second attack? The dynamic stability. A bridge might look stable on paper, but if the wind blows the wrong way, it can shake itself to pieces.
To address the stability objection, Rossetti didn't just point to his numerical simulations. He utilized a highly advanced branch of mathematics called Sturm-Liouville spectral theory.
Sturm-Liouville spectral theory. Explain how this proves the wormhole won't shake itself apart.
Spectral theory is used to find the eigenvalues of complex differential equations.
Let's define an eigenvalue for the listener.
Think of an eigenvalue as a natural frequency of vibration. Let's use your bridge analogy. Every physical structure has natural frequencies.
Right.
If a vibration hits a positive eigenvalue, the structure wobbles but ultimately damps the energy and stabilizes.
Okay.
If a vibration hits a negative eigenvalue, the wobble amplifies exponentially. The energy feeds on itself until the structure tears itself apart.
Much like the famous footage of the Tacoma Narrows Bridge twisting in the wind until it collapsed.
Exactly. So a negative eigenvalue is a death sentence for a wormhole. The throat would vibrate until it's shattered.
Right.
Using Sturm-Liouville theory, Rossetti rigorously computed the spectrum of perturbations for his logarithmic spiral geometry. And he mathematically proved that in this specific topology, there are absolutely zero negative eigenvalues.
None at all.
None.
Okay.
By proving the absence of negative eigenvalues, he definitively proved the throat cannot collapse under dynamic perturbation. Period. It survives peer review.
So Rossetti survives the mathematical gauntlet. He defeats Hawking's vacuum loops. He proves stability with Sturm-Liouville. He outlines the 48K tabletop phase 1 plan.
Yes.
All of this is incredibly dense, revolutionary physical space-time engineering, but this is exactly where the story takes a turn that honestly left me staring at a wall for an hour trying to process it.
We're moving to the information topology leap.
Yes. Because right as we wrap our heads around physical tabletop wormholes and BYIG radar transmitters, Elijah A. Brown publishes his paper.
And this changes everything.
Right. And Brown takes this exact same tensor calculus, all of Rossetti's Einstein-Cartan equations, the torsional shields, the geometry, and he applies it directly to artificial intelligence and data structures.
This represents a monumental paradigm shift in how we understand information. Brown hypothesized that Rossetti's mathematical framework is what we call substrate independent.
Substrate independent, meaning the mass doesn't care what physical material it is running on.
Think about the mathematics of a wave. The equations that govern wave mechanics apply perfectly to water rippling in the ocean. They apply perfectly to sound pressure traveling through the air.
Right.
And they apply perfectly to electromagnetic light traveling through the empty vacuum of space. The math is universal. It works regardless of the physical substrate carrying the waves.
Okay, I follow.
Brown posited that if Rossetti's non-Riemannian geometry is mathematically sound, it doesn't just apply to the physical fabric of Kevlar spacetime. It must apply to any sufficiently complex, structured topology.
Any topology, including the architecture of data.
Yes. Brown theorized that large data sets have a physical geometry to them. So he tested this by building an information manifold. He constructed a massive Neo4j graph database, a vast interconnected web of data nodes.
The paper specifies a network of 7,807 nodes.
Correct. And he structured this data meticulously to test the extremes of the math. The core of the database was a primary corpus of 902 physics literature nodes, essentially all the dense, highly specialized research papers on quantum gravity and wormholes.
Okay, that makes sense.
But then he embedded that dense core into 6 completely different broad auxiliary domains.
Let's list those domains because the sheer diversity is critical. He included massive dumps of ChatGPT conversational logs, Claude reasoning histories, raw GitHub code commits, generalized social media posts, and Wikipedia articles. Utterly diverse, seemingly unrelated data.
The goal was to see if the laws of Einstein-Cartan gravity would spontaneously manifest inside a map of human knowledge. To do this, Brown faced a massive translation problem.
Right, he had to map the physical variables of Rossetti's gravity equations directly onto database metrics.
Exactly.
Okay, this is where it gets absolutely mind-bending. How do you translate the physical gravity of a wormhole into the metrics of a Neo4j database? Walk us through the mapping.
It is beautifully logical once you see it. Let's return to those Frenet-Serret invariants we discussed earlier. In physics, curvature, or kappa, represents how much physical space bends around a mass.
Right.
In Brown's data manifold, curvature translates to the difference in phi scores over the embedding distance between two nodes.
Phi scores. What does a phi score actually represent in a database?
A phi score is a metric of information density, quality, and structural authority. A peer-reviewed physics paper has a massive phi score.
And a random tweet about what someone had for breakfast has a very low phi score.
Exactly. If you map a highly dense, authoritative node right next to a low-quality node in the database, that creates a steep curve in the semantic landscape.
Okay, so a difference in knowledge density creates semantic gravity. Got it. Next is geometric torsion, tau. In physical space, this is the violent twisting of the manifold. How do you twist data?
In the data manifold, torsion equals the interdomain semantic distance multiplied by the connection strength.
Let me parse that. Interdomain semantic distance. So, if physical torsion is twisting space, information torsion is taking two radically different subjects, like a dense tensor calculus equation and a casual social media post, and computationally forcing a high-strength semantic connection between them.
Yes.
You are physically twisting the context of the data.
Precisely. You are forcing a rigid structural bridge across a vast semantic divide. The less related the topics are, the harder the twist required to connect them.
That's incredible.
Finally, you have the radius, $3. In a physical wormhole, this is the width of the throat. In the information manifold, the radius translates to the average semantic degree.
Semantic degree meaning how many other topics is this node connected to?
Yes, the breadth of context. A very broad general concept like science or history connects to thousands of things. It has a massive radius. A highly specialized, deeply obscure concept like the ESP metric artifact in Einstein-Cartan theory connects to very few things. It has a microscopic radius.
So Brown takes Rossetti's physics equations, plugs in these specific data metrics from his 7,807 nodes, runs the math, and what exactly does he find?
He finds that the torsional shield, the exact mathematical barrier of infinite potential that Rossetti proved exists in physical spacetime, exists perfectly and naturally inside the data.
Are you kidding me? A white hole force shield inside a hard drive?
The math aligns perfectly. Brown identified what he termed information throats. These are nodes with a very low radius, highly specialized obscure topics, but with incredibly high cross-domain torsion, meaning they are forced to connect to distant concepts.
Okay.
When he calculated the effective potential at these specific nodes using Rossetti's Einstein-Cartan equations, the potential spiked to 729 times the median of the entire data manifold.
729 times the median. The graph hit the literal wall. The physical math perfectly predicted the behavior of information.
It did. Furthermore, Brown observed the exact same exponential geometric amplification.
Meaning?
In Rossetti's physics, as a path travels through the twisted space, its energy amplifies exponentially. Brown found that as the path length across his data nodes increased, the semantic amplification grew exponentially.
Represented mathematically as roughly 8a to the power of 0.402 times the path length.
Exactly. The curves generated by the physics equations overlaid identically onto the data trajectories.
Okay, proving the math works in observation is one thing. Pointing a telescope at the data stars and seeing a wormhole is incredible. But Brown didn't stop at observation.
No, he didn't.
He didn't just map it, he built the ship to fly through it.
This is perhaps the most computationally consequential part of this entire deep dive. Brown engineered the direct information space equivalent of Rossetti's physical RF engine. He called the system spacetime knowledge injection, or SKI.
SKI. Space-time knowledge injection. If Rossetti uses a massive 45.01 megahertz radio wave pumping into a bismuth crystal to fracture physical space, how on earth do you apply that mechanism to an AI?
You apply the exact same non-minimal electromagnetic coupling mechanism, but you map the variables to the neural architecture of a large language model.
Okay, break this mapping down for me.
In physical space, the driver is the RF field, the electromagnetic energy. In the SKI system, the RF field becomes the attention flux of the LLM.
The attention mechanism. That's how an AI focuses on specific words in a prompt to understand context. So the AI's attention acts as the raw energy.
Correct. In physics, you have contortion, the physical geometric twist generated by the crystal. In SKI, this becomes knowledge graph torsion, the algorithm, forcing those distant semantic concepts together in the latent space.
Okay.
And in physics, the gauge potential defines the state of the electromagnetic field. In SKI, this translates to topic activation inside the neural network layers.
So Brown is treating the massive matrices of the AI's neural pathways identically to the physical fabric of Kevlar spacetime. He is treating the data like it has physical gravity.
Yes, and he ran this entire SKI pipeline on a single standard A100 GPU using the off-the-shelf Gemma 426B open source model.
A single A100 GPU. He didn't use a billion-dollar supercomputer cluster. He used hardware you can rent on the cloud for a few dollars an hour.
The efficiency is the breakthrough. By treating the retrieved information exactly as Rossetti treats physical torsion, the AI was able to traverse massive data distances instantly.
It bypassed the normal, slow, step-by-step associative processing.
It acted exactly like a wormhole, and the empirical results were unprecedented. The AI achieved a perfect 10 out of 10 recall score on targeted fact injection benchmarks with sub-second latency.
Wait. I want to make sure everyone listening understands the magnitude of this. It injected entirely new, highly complex facts across vast semantic divides in less than a second without retraining the base model.
Completely without retraining.
That is a billion-dollar tech breakthrough right there. Retraining a large language model to learn new facts usually takes weeks. Massive server farms, and tens of millions of dollars in electricity and compute costs.
Yes, it's incredibly resource intensive.
And you are saying SKI tunneled through the model's latent space, connecting new concepts instantly, just by hacking the structural topology of the data itself using wormhole math.
Yes, it is a functional, zero-shot knowledge wormhole. It completely sidesteps the computational bottleneck of deep learning.
That is absolutely staggering.
And to fully close the loop on Rossetti's physical theories, Brown even observed the phenomenon of topological hysteresis inside the AI.
Topological hysteresis,
Yeah.
the self-sustaining battery effect we talked about earlier. In physical space, the 500 megawatt ignition burst drops to 3.5 megawatts because the twisted space locks into place and holds its own shape by feeding on the vacuum.
Exactly. Brown found that after the initial SKI injection was performed, the high-energy attention flux burst those cross-domain semantic edges, the data wormholes, retained their torsion for 6 to 24 months in simulated decay tests.
The data literally held its twisted shape long after the initial compute burst was turned off.
The information geometry self-sustained. The AI remembered the connection with near-zero ongoing computational cost, exactly as the physical wormhole sustains its structural integrity after the capacitor banks are drained.
That is amazing.
The physics and the data are perfectly symmetrical.
Okay, let's take a breath and recap the sheer monumental scale of what we've unpacked today, because honestly, this is a lot to process.
It is a simultaneous paradigm shift across two completely distinct scientific disciplines.
We started with Einstein-Cartan theory, learning that by injecting geometric torsion, by physically twisting spacetime, we can generate outward pressure, eliminate the need for exotic matter, and build a torsional shield that mathematically defeats Stephen Hawking's chronology protection conjecture.
Right.
We looked at Rossetti's incredibly specific aerospace engineering blueprint, a 6.66-meter resonance, bismuth-doped yttrium iron garnet transmitter operating precisely at 45.01 megahertz and 482 ohms. We saw a completely viable, perfectly budgeted 48,000 euro phase 1 business plan using Sagnac interferometers to measure localized frame dragging on a laboratory table.
And then we took all of that high-level physical engineering and proved mathematically and empirically that large language models can traverse vast databases using that exact same tensor geometry.
Which forces the ultimate question: why does this matter to you, the listener? Why should you care about the math behind a tabletop wormhole in Italy or the data structure of an AI on a server farm?
Because we are looking at the fundamental unification of reality.
Yeah.
Whether humanity is trying to physically travel to the stars, bypassing the unbreakable speed of light, or whether we are simply trying to navigate and organize the impossibly vast, exponentially growing oceans of AI-generated data. The geometric mathematical keys required to unlock both of those frontiers are exactly the same.
The structural rules of the physical universe are the structural rules of the data universe. Which brings me back to where we started this conversation.
Okay.
We talked about how physics usually presents these unbreakable rules. Clean lines, gravity always pulls, you can't exceed the speed of light, you can't teleport.
But the math shows us that if you twist the manifold, if you change the geometry of the game board, the rules change entirely.
So here's a final thought to mull over as you go about your day. If the complex mathematical structures required to bend physical spacetime to create a physical traversable wormhole are literally identical to the mathematical structures required to instantly connect distant concepts in an artificial intelligence's brain, what does that actually say about the universe we live in?
That's a profound question.
Are we trying to build a physical machine out of metal and BiYig crystals to bend the reality of space? Or are we simply finally learning how to hack the source code of a universe that is just a massively complex database? Keep twisting your perspective and we'll catch you on the next deep dive.
Imagine a dark control room, like just a completely standard, totally unremarkable flat screen monitor, and there's a desktop application running on it.
Right, yeah. Just a normal computer.
Exactly. It's got this dark mode background, neon cyan text, a few, drop-down menus, and there's a button right on the screen that casually says sync time delta.
Which is just wild to see on a standard user interface.
Oh, totally. Because the code dictates that when you click that button, a 500 megawatt radio frequency array fires up and just punches a 10-foot hole straight through the fabric of reality.
It's basically the absolute definition of code bleeding into the physical world. I mean, we're so used to software living in this safe, isolated, digital sandbox,
Yeah.
You put numbers in, a spreadsheet does some math, and a result pops out. It's safe.
Yeah, the stakes are usually just, a crash web browser. Or maybe you lock up your laptop. But welcome to the deep dive, because today we have a journey for you that completely shatters that digital sandbox.
Absolutely shatters it.
Because our source material today isn't some peer-reviewed journal article on theoretical physics. And it isn't an engineering textbook either. We are looking at a literal Python script.
Yeah, and this script is called CHRONOS v9.2 Novier-Rossetti Wormhole Engineering Console.
Honestly, just reading that name on the first line of the file, it gave me this visceral reaction. It's so intense. So our mission today is to look completely under the hood of this software. We're going to examine a program designed to simulate, calculate, and, theoretically, control an artificial wormhole.
Right, the whole thing.
Yeah, we're unpacking the exact mathematical framework, the actual power requirements to tear space-time, the safety mechanisms that supposedly keep the operator from being instantly vaporized, and the actual mission control interface built right into the code.
And what's really fascinating here is the sheer juxtaposition of it all. This code perfectly blends the most mundane elements of standard software engineering.
Like sliders and buttons.
Exactly. Things you interact with every single day. Graphical user interface, widgets, mouse click events, basic password hashes. But it blends those with hardcore, highly advanced physics engines.
Right.
It is actively calculating the geometry of spacetime frame by frame and then mapping it to a literal slider bar.
Okay, let's unpack this.
Yeah.
because my very first instinct when I saw this code base was massive, massive skepticism.
Oh, of course.
Yeah, because it's written in Python. I mean, people use Python to build basic web scrapers or, automate their smart home lights. Python is notoriously slow compared to lower level languages.
Very true.
So how on earth is a Python script running real-time quantum gravity calculations without stuttering, lagging out, and then subsequently crushing the passenger into a singularity?
That is a highly perceptive question, and honestly, it's the first thing any software engineer would ask when looking at this. But the secret here is that Python in this application is really just the steering wheel.
Just the steering wheel, okay.
Right. It's the control layer. The code relies incredibly heavily on specialized libraries, specifically NumPy and SciPy.
Right, those are super common in data science.
Exactly. And when you call a mathematical function in NumPy, Python isn't actually doing the math. It passes the heavy lifting down to precompiled C and Fortran code, which runs at blistering hardware-level speeds.
Oh, wow.
Yeah, so Python is just acting as an orchestrator. It's managing these incredibly optimized mathematical engines running underneath.
Okay, so the Python script is just the friendly face on a massive, highly optimized underlying calculator.
Precisely.
That makes a lot of sense. So let's start where the code starts, which is the architecture of space-time. Because before we can even think about throwing a switch and traveling through a wormhole, this software has to physically construct it in a three-dimensional computational space, right?
Yeah. I mean, space-time has a topology, a shape. You can't just draw a circle on a screen and call it a Stargate. It doesn't work like that.
Right, obviously.
So the code handles this geometry using a specific class named exact logarithmic spiral 3D.
Which is a mouthful. But I noticed it defines the shape using three specific hard-coded parameters. It sets A to 0.1, B to 0.012, and C to 0.05.
Yeah.
But what do those numbers actually dictate in physical space?
So those parameters define the fundamental growth and twist of the wormhole's throat. Parameter A, that sets the initial base radius.
Okay.
Parameter B dictates the flaring out, so how quickly the tunnel expands as you move away from the center point.
Got it.
And C controls the torsion, or basically the twisting rate of the spiral. And from those three tiny numbers, the code uses NumPy arrays to calculate the tangents, the second derivatives, and the third derivatives along this entire geometric curve.
So to put this in perspective for you listening, it's like using a 3D modeling program to design a spiraling staircase. If you're building a staircase, you need to know exactly how tight the inner curve is, right?
Yep.
And how steeply the steps rise and how aggressively the whole structure twists upward.
That's a great analogy, yeah.
But instead of calculating the stress on wood and steel beams, this code is mathematically modeling the structural integrity of reality itself.
And that structural integrity is evaluated by a significantly heavier piece of the code. It's called the Rossetti metric engine. This is where the simulation shifts from just drawing a 3D shape to interrogating the actual physics of that shape.
Yeah, and this section of the script was incredibly dense. It's calculating things called Christoffel symbols, Riemann tensors, Ricci tensors, and a Kretschner scalar.
Oh yeah, heavy math.
And I am definitely going to need you to save us from drowning in jargon here. Let's start with tensors. What are they, and why does this software actually need them?
Well, if we connect this to the bigger picture of general relativity, Einstein taught us that gravity isn't this invisible magnetic pull. Gravity is the literal physical curving of space-time caused by mass and energy.
Right.
So a tensor is simply a complex mathematical tool that physicists use to describe exactly how that fabric is bending and stretching at any specific microscopic point.
Okay, like mapping the contours of a trampoline when someone is standing on it.
Precisely, yeah. So the Christoffel symbols describe how your coordinate system changes as you move along that curved surface.
Okay.
Then the Riemann tensor goes a step further. It measures the actual curvature, like how parallel lines will eventually intersect in that warp space. And then the Ricci tensor averages that curvature out to measure how the volume of an object changes as it moves through the space.
Okay, so it's layers of detail about the shape, but what about the Kretschner scalar? That one sounded important.
Oh, it is. That is the ultimate invariant measure.
Invariant meaning.
Meaning it stays exactly the same no matter who is observing it or how fast they are moving. It's absolute. The Kretschner scalar takes all the complex directional data from the Riemann tensor and just boils it down into a single absolute number that represents the total objective curvature of space-time in a vacuum.
Wow.
It tells the software, without a shadow of a doubt, exactly how warped reality is inside that tunnel at any given moment.
But doing that math live seems computationally impossible. I mean, the code notes it uses a tiny interval, EPS equals 1e5, to calculate these derivatives using what it calls finite difference methods. Help me visualize what that actually means.
Sure. Imagine you're a hiker, right? And you're trying to map the precise slope of an invisible mountain, but you're blindfolded.
Sounds dangerous.
Very. You can't see the whole mountain. So you take one microscopic step forward, you feel the change in elevation, and you write it down.
Right.
Then you take another microscopic step. That is essentially the finite difference method. The EPS equals 1e5 is the size of the step, so 100,000th of a unit.
That is tiny.
Exactly. The software is evaluating the gravitational stress on the wormhole by taking these microscopic computational steps across the entire 3D topology.
And again, I go back to my skepticism here, because calculating thousands of tensors at microscopic step intervals in real time, doesn't that just crash the system?
Well, the code developer anticipated that. There is a very prominent developer note stating this physics engine is CPU stable.
CPU stable?
Right. It achieves this stability by relying on advanced SciPy integrators. Specifically, it uses a function called solvap, utilizing the DOP 853 method.
DOP 853? I mean, that sounds like a specialized router, not a math function.
I know, right? It stands for Dorman-Prince 8th order.
Okay.
It is an incredibly sophisticated mathematical algorithm designed for solving differential equations.
Yeah.
Rather than calculating every single point blindly, DOP 853 is adaptive.
Adaptive how?
It uses 8 different simultaneous approximations to check its own work. If the curve of spacetime is relatively smooth, it takes larger computational steps to save processing power.
Oh, that's smart.
But if the curvature suddenly spikes, like, say, near the throat of the wormhole.
Right, where things get crazy.
Exactly. It automatically shrinks its step size down to maintain pinpoint accuracy without overloading the processor.
Oh, that is brilliant. So it dynamically allocates its brain power based on how dangerous the gravity is getting in the simulation.
Yeah, exactly.
And it explicitly runs all of this hardcore Einsteinian math on the standard CPU, leaving the computer's graphics card, the GPU, completely free to just handle the visual rendering of the 3D spiral on the monitor.
It is treating the fundamental laws of general relativity the exact same way a modern video game engine processes, like a bouncing ball. It utilizes an adaptive physics tick rate to ensure the simulation never freezes.
Man, okay, so we have the architecture. We've mapped out the tensors, the curvature is stable, the NumPy arrays have built the spiral. We basically have a pristine, mathematically sound map of a wormhole.
We do.
But a map of a door doesn't turn the doorknob. How do we punch this hole into the physical room? We have to move out of the realm of pure geometry and into the realm of raw physical power.
And this transition takes us straight into the RF engineering engine.
Yes. And this was the moment the code felt uncomfortably real to me. Because it isn't using some fictional glowing blue space crystal to open the wormhole. It uses standard terrestrial radio frequencies, RF engineering.
Which is fascinating. The software defines a robust set of universal constants. You've got the speed of light, the gravitational constant, Planck's constant.
Basically the standard physics toolkit.
Exactly. But nested right below those are the active engineering variables.
And here's where it gets really interesting for you listening. The power variables. There is a specific constant named Pignition NMW, and it's set to 500.0. And right below it, PSU stain NMW is set to 3.5. We are talking megawatts.
Yeah. To put 500 megawatts into perspective, that is roughly the electrical output of a mid-sized commercial nuclear reactor.
Good Lord.
It is an absolute ocean of energy.
It's like trying to start a cold engine on a massive diesel freight truck in the dead of winter. It requires an absolute gargantuan surge of energy, 500 megawatts of raw radio frequency power, just to spark the throat of the wormhole, to literally force reality to tear.
Right.
But the code implies that once the hole is punctured, once the anomaly is locked, it only takes 3.5 megawatts to hold it open.
And the underlying physical mechanics explain that drop in power, because the code tracks a variable called radian, that's the dynamic radius of the wormhole's throat.
Okay.
Before ignition, it defines a baseline state, R0 theotrope, and that's set to exactly 0.01 meters.
1 single centimeter.
1 centimeter.
So it starts as this microscopic, invisible pinprick in the air.
And then the 500 megawatts is applied, but not just blindly dumped into the room. It has to be applied at a highly specific resonant frequency. The code dictates FRESMHC equals 45.01.
45.01 megahertz. But why that specific frequency?
Well, in physics, every physical cavity has a resonant frequency. It's a pitch where waves naturally amplify and bounce perfectly.
Like glowing over the top of a glass bottle.
Yes, exactly like that. If the initial 1 centimeter geometric distortion of spacetime acts as a cavity, hitting it with 45.01 megahertz of RF energy causes the spatial fabric inside it to rapidly oscillate and expand.
And when it hits that threshold, the logic loop triggers a lock-ready state. The Python script actually checks if the effective power pushing into the cavity is at least 98% of the ignition power.
Right. It has to be close to perfect.
And if it hits that mark, the code commands the dynamic radius to expand from 1 centimeter to an astonishing 3.33 meters.
3 meters, over 10 feet in diameter.
I mean, that is a doorway.
It really is.
That is large enough to drive a small utility vehicle through, or at least comfortably walk a whole research team through side by side. But getting to that 3.33 meter state isn't just about dumping power. The code reveals this incredibly dangerous electrical balancing act.
Oh, you mean the impedance mismatch?
Yes. I need you to explain this because the implications here are terrifying. I know what impedance is in, like audio equipment.
Right.
If you plug a high-end heavy-duty speaker into a cheap amplifier, the sound doesn't just get quiet, it distorts horribly. Because the electrical resistance, the impedance, doesn't match. So the electrical signal hits the speaker coil and physically bounces backward into the amplifier.
That is the exact mechanism. Now, take that audio equipment analogy and replace the speaker with the literal vacuum of space-time.
Okay.
And replace the amplifier with a 500 megawatt nuclear-powered RF generator.
Oh my God, if that energy bounces back.
It would be an instantaneous catastrophic explosion.
Wow.
Yeah, space-time has its own intrinsic impedance. The vacuum of space inherently resists being torn open, and the Python script acknowledges this by hard-coding a variable called z_aim, set precisely to 482.45 ohms.
And the control panel literally features a real-time visual readout for the operator called return loss, and it's measured in decibels.
Exactly. The operator is actively monitoring how much of that 500 megawatt ignition burst is being successfully absorbed by the wormhole and how much is reflecting off the fabric of reality and surging back toward the control room.
So if the RF array is in tune to exactly 482.45 ohms to match the impedance of the spacetime cavity, the anomaly will fail to expand and the energy will rebound.
Which would be catastrophic, yes.
It basically turns theoretical physics into gritty, high-stakes electrical engineering.
It really does.
You are tuning the fabric of the universe, the same way an old-school ham radio operator tunes an antenna dial to remove static. It is so remarkably practical.
And that practical engineering seamlessly brings us to the next massive problem the operator faces.
Right, because let's assume we get it perfectly. We matched the 482.45 ohm impedance. We slammed 500 megawatts of 45.01 megahertz energy into a 1 centimeter pinprick, and it blossomed into a stable 3.33 meter anomaly hovering in the center of the room.
A perfect execution.
The immediate, unavoidable question you would have as you stand there bathed in its glow is, can I survive walking into it?
Which takes us straight into the safety systems managed by the torsional calorimetry engine.
And let me tell you, safety is a very relative term in this code base, because looking at the variables in this calorimetry engine reads like a checklist of the universe's most horrific ways to die.
Truly.
It's constantly calculating the local vacuum energy, the shifting electromagnetic energy, and a thermal dynamic it calls the blue sheet effect.
Ah, yes, the blue sheet. This is a foundational concept in wormhole physics.
Right.
When light or ambient energy falls into any massive gravitational well, like a black hole or a wormhole, it accelerates. And as it accelerates, its wavelength compresses, causing it to blue shift. Its frequency increases, which means its energy increases exponentially.
So wait, any stray light bulb in the room or any radio waves from a nearby cell tower, they get sucked into the throat of the wormhole and instantly compressed into ultra-high frequency radiation.
Exactly. The energy can become infinitely blue shifted at the throat, creating this incinerating, blinding wall of lethal radiation, a literal blue sheet of death.
Wow. And the software is actively tracking the temperature of that sheet, but it doesn't stop there. It also includes dedicated formulas for variables named Hawking temperature and Hawking luminosity.
Right, Hawking radiation, the theoretical thermal radiation released by black holes due to quantum effects near the event horizon.
Right, Stephen Hawking's famous discovery.
Exactly. The software treats the artificial singularity at the wormhole's throat exactly like a black hole horizon. It's calculating the exact thermal flux, mapping out the radiation dose profile generated by the anomaly, and even factoring in high-energy physics, like a UV cutoff limit.
So what does this actually mean for the person sitting in the chair staring at the screen? The codebase includes a class called the alarm monitor that pulls all of this horrific telemetry in real time. And the thresholds it uses to trigger alarms are just staggering.
They are.
It throws a critical alarm if the power exceeds 1,000 megawatts.
Which is double the required ignition power. That implies a runaway reaction. The RF array is basically dumping energy uncontrollably into the cavity.
Then it throws an alert if the blue sheet temperature exceeds 6,000 Kelvin.
And for context, 6,000 Kelvin is roughly the temperature of the surface of our sun.
Oh, cool.
Yeah, so the software is warning you that you have accidentally created a localized solar surface inside your laboratory.
It's a casual alert for a sun in the room. And then it throws a warning if the ambient radiation dose hits 1E3 sieverts per second.
Let's talk about sieverts, actually, because that number, 1E3, a millisievert per second, it might sound small to a layperson. But radiation exposure is cumulative. It's all about accumulated cellular damage.
Right.
If you are absorbing a millisievert every single second, standing near that 3-meter doorway for just 2 or 3 minutes would guarantee acute, fatal radiation sickness. Your DNA would be systematically shredded.
So, with a miniature sun baking the room, Hawking radiation spilling out everywhere, and fatal gamma rays accumulating by the second, how in the world does the system expect a human being to survive, stepping through this doorway?
Well, the code provides an incredibly elegant geometric solution, the torsional shield indicator.
This is my absolute favorite part of the entire interface. It's literally a graphical widget on the user's dashboard, a literal shield gauge.
Yes. And the logic driving it is deeply tied to the physical state of the anomaly. The code runs a Boolean check, asking, is the dynamic radius currently greater than 3.0 meters, and is the lock state true? If both those conditions are met, the variable shield strength is instantly, forcefully set to 100.0.
And the developer's intent here is perfectly clear because they left a comment right in the Python script.
Yeah.
It says in Italian, 100% say wormhole aperto. 100% if the wormhole is open.
Right.
And it updates the screen text to say impenetrabile, impenetrable.
And the physics implication here is phenomenal. It suggests that if the wormhole is fully open, like if the geometric topology is complete and locked at full diameter, the torsional twisting of the spacetime fabric itself acts as a flawless, impenetrable shield against the Hawking radiation and the blue sheet.
So the walls of the spiral actually deflect the internal thermal flux away from the passenger traversing the center of the tube.
Exactly.
But the truly terrifying caveat is what happens when it is not fully open.
Right, because the shield isn't binary. It scales dynamically.
Of course it does.
The Python script calculates a really complex ratio. It measures how close your actual applied RF power is to the ideal 500 megawatt ignition power. And it measures how perfectly your frequency matches the 45.01 megahertz resonance. The strength of your radiation shield is a direct mathematical product of your tuning accuracy.
So if you are sitting at the console and you're clumsily turning the dial on the RF power, overshooting the impedance, fluctuating the resonance, your shield drops. It drops to 60%, 40%, 20%, and you start actively cooking the room in lethal radiation.
Exactly. The impenetrable state only exists in a state of absolute perfect resonance. It demands perfection from the operator.
Yeah. Okay, so let's assume we are perfect.
Let's hope so.
We tuned it. The shield is impenetrable at 100%. We are totally shielded from the heat and the radiation, but surviving the heat doesn't matter if the tunnel itself crushes us. I mean, gravity naturally wants to snap this unnatural 3-meter hole shut the millisecond it opens. How does the software stop the universe from violently correcting itself while you are halfway through the passage?
That requires us to dive into the stability engines. This is really the heart of maintaining the passage.
And the code contains a module called the NEC verifier. And honestly, this completely upended my understanding of theoretical physics.
Yeah.
Every sci-fi movie, every theoretical paper on traversable wormholes says the exact same thing.
Right, the exotic matter requirement.
Yes, to keep gravity from crushing a wormhole shut, you need something with a negative energy density to prop it open. You need exotic matter.
That is the null energy condition, or the NEC. In standard physics, all physical matter has a positive energy density. It satisfies the NEC.
All right.
To violate the NEC, to create that outward gravitational pressure you would need exotic matter, which likely does not even exist in our universe. But what makes this code truly revolutionary is that the NEC verifier continuously tracks whether the condition is violated, but it explicitly sets a beta flag, exotic matter equals false.
Wait, it is holding a 3-meter wormhole open without exotic matter. How is that mathematically possible within the confines of this script?
The software achieves this stability by relying on what it calls a ghost-free mathematical check utilizing torsion fields.
Torsion fields. Let's break that down for the listeners.
Standard Einsteinian relativity assumes that spacetime can curve, it can bend, and it can stretch, but it assumes it does not twist. There is no intrinsic torsion.
Right.
But in extended physics frameworks, like the Einstein-Cartan theory, spacetime can have torsion. It can twist on a microscopic level. The Python script actually defines 3 specific variables for this field: alpha, beta, and gamma torsion coefficients.
Yes. It sets alpha tors to 1.0, betators to 0.5, and gammators to 0.1.
And those aren't arbitrary numbers. The ghost free check function evaluates a very strict mathematical inequality. It checks if 4 times alpha plus 2 times beta plus gamma is greater than 0.
Okay, 4 times alpha plus 2 times beta plus gamma 0. What happens if it equals 0 or goes negative?
Then you generate a ghost.
A ghost.
In high-level physics mathematics, a ghost is a state with negative kinetic energy. It basically represents a catastrophic mathematical instability where the equations unravel and the physical system violently rips itself apart.
Oh, wow.
By ensuring that specific mathematical formula stays positive, the system proves the spacetime has no ghosts. It uses the intense microscale twisting of the torsion fields to dynamically prop the macroscopic curve of the wormhole open, entirely bypassing the need to feed it impossible exotic matter.
That is wild. It's using the twist of space to hold the curve of space open.
Exactly.
But a delicate balance like that has to be monitored continuously.
And that monitoring is handled by the BSS Nevolution 1D engine.
Yeah, I saw this acronym everywhere in the stability
Right.
section, BSSN. It's constantly tracking these constraint variables named chi, k, and gam, and logging whenever they violate their parameters, recording HVOL and MVOL. What is BSSN actually doing here?
BSSN stands for Baumgart, Shapiro, Shibata, Nakamura.
Wow, okay.
Yeah, it is a highly robust mathematical formalism utilized in the field of numerical relativity. When astrophysicists use supercomputers to simulate the violent collision of 2 black holes, standard Einstein equations tend to crash the simulation because the numbers shoot off to infinity.
Right.
BSSN reformulates the equations to remain numerically stable over time.
And this desktop software is using a supercomputer black hole collision algorithm to monitor our 3-meter doorway.
Exactly. It runs a one-dimensional BSSN evolution down the exact length of the wormhole's throat. It is continuously tracking the numerical stability of the simulation. And the most critical variable here is chi, which represents the conformal factor. Conceptually, chi acts as the scale factor of the spatial geometry itself.
So what does that actually mean for the human being stepping through the portal? If I am sitting at the console watching the chi value drop, what is physically happening to the tunnel?
If the BSSN chi value drops below 0.1, the alarm monitor triggers a massive system-wide alert. Because a dropping chi value means the spatial scale is shrinking uncontrollably. The numerical stability of the spacetime simulation is basically unraveling.
So the math can no longer support the geometry, and the space is actively collapsing.
Right.
It's like a video game crashing and throwing a blue screen of death. But the blue screen is you being physically crushed into a quantum singularity.
It is the ultimate fatal error. The code literally tracks the unraveling of reality.
Wow. Okay, so let's pull back from the abyss for a second. We have the underlying math. The DOP 853 engine is humming, the torsion fields are ghost-free, the BSSN chi factor is stable, and our shield is 100% impenetrable.
All green lights.
Who is managing all of this? What does the person in the chair actually see? We have to talk about the user experience of wielding godlike power.
Yeah, this is where it gets really fun. The visual interface of CHRONOS v9.2 Nova is built using PyQ5. That is a completely standard open-source framework used by developers worldwide to build basic desktop graphical interfaces.
Really, just a normal library.
Totally normal.
But the aesthetic choices the developer made are incredibly deliberate. The script specifies a very precise dark mode. The background is set to hexadecimal, #05051 now, which is this deep, oppressive, almost void-like navy black.
Right.
And all the system text and readout values are rendered in a harsh neon cyan, #000FSEC.
It creates this deeply isolating cyberpunk atmosphere. I mean, it looks exactly like what you would instinctively want a rogue underground wormhole control console to look like.
Yeah. Totally.
But the genius of the interface isn't the colors, right? It's the widgets, the visual readouts where the software attempts to visualize the fundamentally unseeable.
Let's walk through those widgets.
Yeah.
Because they are wild.
First, the operator monitors the space-time curvature heat map. The code utilizes a color map literally named plasma to display the effective potential. It highlights the literal gravitational stress points along the throat of the wormhole, mapped out on a 2D graph that shifts and pulses in real time as the torsion fields fluctuate.
Just a plasma heat map of gravity.
Yeah.
Casual. And beside that, you have the live spectrogram.
Which uses the Inferno color map. This widget tracks the raw radio frequencies.
Oh, okay.
Yeah, so you can visually watch the 45.01 megahertz waves battling against the 482 ohm impedance of the universe, basically ensuring the return loss stays in the safe zone.
But the centerpiece, the widget that actually takes up the center of the screen, is the software wormhole 3D viewer.
This is the sole component that utilizes the computer's GPU if one is detected. It takes the NumPy arrays from the geometry engine and renders the exact logarithmic spiral using 4,000 individual connected data points.
And it isn't static. It rotates continuously.
Right, it's alive.
As you pump the 500 megawatts in, you actually watch the wireframe drawing scale up and expand from a microscopic centimeter into a massive 3-meter tube drawn live based on the underlying tensors.
Just imagine sitting in that dark room.
Yeah.
The walls are physically vibrating from 500 megawatts of RF power, and you are staring at a plasma-colored heat map of reality stretching on a $200 flat-screen monitor.
The formatting is so unsettlingly normal.
And that normality extends to how you actually pilot the system, which brings us to the dual wormhole controller.
Right, because opening a hole in the room is completely useless if it doesn't go anywhere. You have to point it. And the console features a widget called the World Map widget. The code calculates the geographical distance for a round-trip mission between your origin coordinates and your destination using the Haversine formula.
The inclusion of the Haversine formula is such a brilliant detail. If you are trying to calculate the distance between 2 points on Earth, you can't just use standard flat plane geometry.
Because the Earth is round.
Exactly. The Earth is a sphere. The Haversine formula specifically calculates the great circle distance between 2 points on a sphere using longitudes and latitudes.
Okay.
So if you are punching a straight line tunnel through higher dimensional space, the software mathematically accounts for the fact that the Earth's crust is literally curving away from that tunnel.
And the default mission hard-coded into the Python script, like the placeholder text sitting in the input boxes when you launch the app, is intensely specific. The origin is set to latitude 41.9, longitude 12.5.
Those are the exact coordinates for Rome, Italy.
And the destination is set to latitude 40.7128, longitude negative 74.006.
New York City.
Rome to New York, in an absolute instant.
Yeah.
But bridging the spatial distance isn't even the hardest part of the mission planner, because the user interface features an input field for the mass of the payload, which defaults to 1,000 kilograms. But right next to the mass input, there's a field plainly labeled stay in days.
This is arguably the most mind-bending conceptual leap in the entire code base, the management of the time delta.
I stared at this code block for 20 minutes. There is a physical button on the UI that just says, sync time delta. How on earth does a simple button synchronize time?
Well, the fundamental laws of relativity dictate that space and time are deeply interconnected.
Right.
If you traverse a wormhole, you are bypassing traditional space, which means you are also inherently traversing time. Time dilation means that the clocks at the origin point in Rome and the destination point in New York will immediately begin to desynchronize due to the difference in gravitational potential and traversal speed.
So if you step through to New York, spend the weekend there, and step back, the Earth might have aged 100 years while you were gone.
Precisely. You get a massive paradox. So to prevent chronological paradoxes, the dual wormhole controller initializes 2 entirely separate simulation engines in the background. It names one instance OutTBN and it names the other return.
Wait, really?
Yes, it is effectively running 2 parallel realities simultaneously to keep the endpoints tethered.
So if I want to stay in New York for 3 days, I type 3 into the stay box. What does the algorithm actually do?
The algorithm calculates the precise time dilation curve caused by the outbound trip, projects 3 days of standard time passing at the destination, and then artificially adjusts the physical geometry and torsion of the return wormhole metric.
It changes the shape of the return tunnel.
Yes, it actively alters the gravitational stress of the return trip so that the time dilation backwards perfectly cancels out the time dilation forwards.
So that when you step back into the Rome laboratory, it has been exactly 3 days there too.
Exactly. You don't arrive a week before you left, and you don't arrive 1,000 years in the future.
The code makes resolving grand temporal paradoxes a simple administrative task. A quick algorithmic offset managed by a mouse click. sync time delta.
It's beautifully simple on the surface.
And speaking of administrative tasks,
Hmm.
none of this, absolutely none of this god-tier manipulation of physics, time, and space works without first passing the security check.
Oh, the authenticate function.
You would think that a machine capable of generating a literal solar surface and tearing a hole in time would have, iris scanners, subdermal DNA sampling, or rotating quantum key cryptography.
You'd think.
What does the security protocol actually rely on?
It looks for a plain text file.
A text file.
Yep, saved in the exact same folder as the script, called key.txt. When the operator types their password into the dark mode login box, the Python script runs a totally standard SHA-256 cryptographic hash on the input and just compares it to the hash stored in the text file.
Standard web login protocol.
Literally standard.
If you misspell the password or if you accidentally deleted key.txt from your desktop, the all-powerful PyKey-T5 user interface simply throws a little gray default pop-up message box right in the center of the screen that says denied.
Invalid key.
Sure.
It is so remarkably grounded.
It anchors the infinite possibilities of the universe in the most mundane realities of IT security. Imagine possessing the ability to collapse the universe into a blue sheet of radiation, but you're permanently locked out of the system because you forgot where you saved a 1 kilobyte text file.
That's modern software for you.
So as we step back and look at the entirety of CHRONOS v9.2 Nova, we aren't just looking at a theoretical idea scribbled on a university whiteboard. We're looking at a fully architected, runnable piece of software.
We are. The script takes the heaviest, most mathematically dense concepts known to theoretical physics, frame dragging, Kretschmer scalars, the null energy condition, BSSN stability equations, Hawking radiation, and it fundamentally treats them as practical, solvable engineering problems.
It hooks up the fabric of spacetime to standard graphical slider bars. It links the terrifying expansion of a wormhole throat directly to a terrestrial power gauge.
It takes the esoteric, unseeable twisting of an Einstein-Cartan torsion field and slaps it onto a highly readable polar plot.
It strips away the mystical, terrifying nature of the cosmos and transforms it into an application you can comfortably operate with a standard computer mouse.
It's chilling, honestly.
Which brings me to a final provocative thought for you, our listener, to mull over as we wrap up this deep dive. Something that truly stuck with me as I scrolled to the very bottom of this script.
The telemetry logging system.
Yes. Down at the very end of the file, there is a class simply named Mission Logger. Because naturally, any robust software needs to log its errors and operations, right?
Of course. It automatically generates a standard CSV spreadsheet and a JSON file.
It names the file with the current date and time. And every single millisecond of the mission, all of this godlike telemetry is quietly written into a mundane little spreadsheet. It logs the timestamp, it logs the dynamic radius of the hole, it logs the RF power output.
But right next to those standard columns, it logs the BSSN mathematical stability violations.
Yep.
It logs the Ricci scalar curvature. It logs doses verse, which is the active lethal radiation dose in the room.
It is diligently tracking the tearing of the fabric of spacetime on an Excel-compatible spreadsheet.
It really forces you to seriously wonder if humanity ever does figure this out.
Right. If we ever do build a physical machine that can bend the universe, piercing reality with 500 megawatts of raw power.
Will it look like the movies? Will it be some mystical, glowing alien artifact, a massive ring of unknowable metal hidden deep in some subterranean government bunker?
Or will it just look exactly like this? A standard desktop application built in Python, complete with a sync time delta button, a basic password text file, and a little gray pop-up warning alert when your space-time simulation accidentally runs out of system memory.
We like our software to live in a safe digital sandbox.
But sometimes the code just becomes reality. And suddenly, the diagnostic X-ray of the universe isn't so clean anymore. We've stepped completely out of the murky waters and right through the wormhole. Until next time.